Hello all, good evening. So in this video, I'll be sharing to you the insights that I got from my submission towards a project real fake job posting prediction. The dataset has been taken up from Kaggle, and the problem statement aims towards getting the insights and studying the EDA and statistical analysis and probabilistic analysis of both real and fake job postings. So, if I tell about the dataset contains around 18,000 job descriptions, out of which 800 are fake. So this clearly means that the dataset is imbalanced. So accordingly, what I have done in this business case is that I have done EDA and statistical analysis, and also I have done machine learning modeling as well, and also I have documented each and everything in a blog, in a Medium blog, which I will be showing in the end. So as I can see that these are the columns that my dataset has. All these above columns are my input features that are present, and this is the output column, fraudulent, whether job posting is fake or not. So if I see in this on in all these columns, I can see that some of these columns are numeric columns, some of them are categorical, and some of them are also textual columns as well. So we will study each and every of these columns, and accordingly we will draw insights from all these columns, and accordingly we can draw insights and recommendations both. So first of all, what I have done is I just imported some basic libraries that I need for my dataset, and this is my dataset that I have imported here using pandas. As I can see that this is my dataset that it's been provided to us. So I can see that some columns are categorical columns, some are textual columns, and some are numeric columns as well. And this is my final output column, fraudulent or non-fraudulent. So these are my columns. I can see that these are all my columns, and when I do df.shape, I can see that I have total of 18 columns and around 17 to 18,000 of rows I have. Now when I do the df.info, I can see that there are many columns of different data types I have. Some are int, some are object, but majority of them are object. So accordingly, when I check all my null values, so I can see that majority of my columns have a lot of null values. There are only a few columns which don't have any null values. So before considering any analysis or before considering any machine learning modeling, we need to treat these null values as well. So if I just normalize this, I can see that different columns have different percentages of null values. So we need to treat all of them. So first of all, I can see that since my dataset is imbalanced clearly, as I talked about in the initial part of this video as well. So I can see that 95% data lies towards class 0, that is its real job, and only 4 less than 5% it lies towards fraudulent jobs, that is fake jobs. Now when I go to my heat map to see the null values, I can see that some columns have no null values, but some columns have a lot of null values which we need to treat up. Now I just do a basic df.describe to just see a basic description of my dataset, and accordingly I just do a bit of more statistical analysis based on location, based on profession, based on fraudulent, non-fraudulent. After that, I do a basic pre-processing to just check first of all the null values. This is just a basic plot of the null values that are present. So I can see that some columns have a lot of null values, some columns don't have any null values, and some columns have less null values. And these are the percentages that we got from above. These are the number of unique rows, unique values in any corresponding column that we have. And we also have found the categorical columns. Now I can see that in my dataset many of the columns that they were of type object. So all the columns that are of type object, I did just basic pre-processing. I filled all my null values with no space at all. This way all majority of the columns null values have reduced down to 0. And for some 2-3 remaining columns where some values are left, what I have done, I have filled them with another category as employment unavailable, experience unavailable, and unsatisfied, unspecified. At the end, I can see that my dataset doesn't have any null values now, so I can proceed further for analysis and machine learning modeling. Now, I can see that there are 4 text columns that are present. What I do is I combine all these 4 text columns just to get some more insights on the number of URLs, phones, and emails. Because upon studying the dataset, you will see that all of my these 4 columns have some URL, phone, and email in this format, hash, 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 and at the end they have underscores. So I use this one observation to draw more into my analysis, and accordingly I just made a distribution of URLs, distribution of phones, and distribution of emails in my dataset based on the count. If I go even further, it's just basic df.head, and I just obviously created number of URLs, and these 3 columns also I created. Now if I start to work on my text data, so for working on text data, I need to first import some packages like word tokenizer, stop words, wordnet limitizer, porter stemmer to work on this even more. So before I start lemmatization, I need to also do some pre-processing as well. So for pre-processing, what I have done is I've removed all the characters except for the alphabets. I converted everything into lower, I split it into tokens, and then I clean my tokens. And at the end, either I can consider lemmatization or I can consider stemming. But for the most part of this project, we'll be considering only stemming. Accordingly, we did the processing, we applied the process function, and we did the pre-processing that is required for all these 4 columns. Now I can also see that my location column is mentioned in this format as country name, state name, and city name. So I can obviously split all these 3 values which are separated by commas, and I can, based on the country, state, and city, I can get further insights. And that also I've gotten these are the insights based on states, these are the insights based on cities, and these are the insights based on countries. For both fraudulent and non-fraudulent, the insights I have got. Similarly, I have gotten some insights based on my experiences, similarly based on some. Okay, so now here what I have done is I have just split my database data frame into 2 separate fraud and non-fraud visualizations. The reason that we have done is very simple. I need to study my data set, my textual 4 columns based on different data set, based on non-fraud jobs and based on fraud jobs. So what I have done is it's a amazing visualization that is mentioned over here, is that there are 2 separate images that I've considered over here as thumbs up and thumbs down as template images. So the reason that I've use them is to create word clouds. The only difference is that instead of rectangular word clouds, I have considered these templates, thumbs up and thumbs down, to create my word cloud. So for non-fraud jobs, I have considered thumbs up, and for fraud jobs, I have considered thumbs down. So these 2 images are for company profile. Similarly, I can do the same thing for description as well. Description non-fraud jobs, description fraud jobs. Similarly, I can do the same thing for requirements non-fraud, and then requirements fraud. And then accordingly I can do it for benefits non-fraud, and then benefits fraud. I can do it. Now there are some additional visualizations as well which we are not able to, unfortunately I cannot show it over here, but all these visualizations which are not are not getting visualized over here since they are plotly, I have incorporated them in my blog, which I'll be showing up in the last part of this video. So there are some other visualizations based on my experience and count that I have shown over here. This is based on my education. This is based on my employment type. And yeah, there's some blank visualizations. We'll see them, all of them, in the end of this video. So One more thing that I observe in my there's one, we have salary column. In salary range column, what we have minimum value and we have maximum value. So the syntax is mentioned as minimum dash maximum. So using this insight, what I can do is I can create two more columns based on this salary range, and accordingly I can apply some pre-processing in these two columns as well to get some insights. So accordingly, I have achieved some insights based on salary, minimum salary and maximum salaries as well, which I will show you in the end. Another thing that I have done is now I have combined all the columns that we have in our data set just to get a text idea what we have. Okay, and accordingly we can run a simple function to get the length of the text. So accordingly, if I generate my plots over here, KD plot, I can see that the real job posting where the jobs are not fraudulent, since it's zero over here, have more amount of length of text as compared to the fraud jobs. So this is one analysis that I can definitely get out of this. Now similarly, I've just defined simple histogram functions and count plot functions, and based on them I'll just get my insights for every other input feature with respect to the output column. So this is my insight based on the employment type for fraudulent, non-fraudulent. This is for has questions. This is for has company logo. So based on this plot, I can make an analysis that those companies which have a company logo, there are more chances of that company being less fraudulent as compared to those companies which don't have a logo, and I think it makes sense as well. So similarly, we can get more insights based on other columns as well, like number of URLs that we have in our dataset with respect to the count, based on the mobile phones, based on the emails. Now this is based on my required education that we have, based on, now this is just another line plot that I've done based on number of emails and number of URLs. Now this is just another sort of variation towards word cloud. Here I have just considered the nouns for all these four columns: profile, company profile, description, requirement, benefits. I got the nouns from them in the above code, and then accordingly I just made another set of word clouds for here just to get some insights as well from here. So this is company profile nouns for fraud data, for non-fraud data, description nouns for fraud data, non-fraud data, requirements nouns for fraud data, non-fraud data, and benefits nouns for fraud data and non-fraud data. Accordingly, there are some plots as well which are not visible. No issues, we can see them in the end. Industry. Now if I talk about industries and functions, so these are the top 10 industries which are mentioned in our dataset. I can see that IT and CS are the highest ones, have the highest count. IT and sales functions plots have the highest count. Now I can easily do some statistical analysis based on my heat map. First of all, I can see that the extra columns that I created, based on that I can see that the number of phones and number of emails have a high correlation amongst each other. Accordingly, we can get some more insights for other columns as well, like has company logo and has questions, and for other columns as well we can get the insights that we need. Now here comes the statistical analysis part. Now what I have done over here is that for two sets we have created the KD distance plot. Fraudulent is equal to 1, fraudulent is equal to 0, and we can clearly see that the data where the our data set isn't fraud, where the jobs are real, it has more text length as compared to the ones which are fraud, and we saw this analysis above as well, so it's clearly aligned with that. Similarly, the same analysis can be done for other columns as well, like this is for questions, has questions. This is another for has questions only. This is just another representation. This is for has logo. This is a fraudulent with our employment type. This is for our telecommuting. This is for experience, education. Accordingly, this is for has company logo. So here also I can see that the companies which have logo have higher text length as compared to the one which are fraudulent. So yeah, similarly I can do the same things for other columns as well: employment type, experience, education. Accordingly I can now get it for number of URLs as well. So I can see that the dataset where the fraudulent, where the data is where the job posting is real, there I can see that the number of URLs are even higher compared to the ones where the jobs are fake. Accordingly I can get my more insights on other columns as well: number of phones, this is number of emails. And then I also have done the hypothesis testing. So hypothesis testing basically is the process where for every other column we do a hypothesis assumptions, and accordingly we check whether these assumptions that we have considered are they true or they are false. So these hypothesis testing can be done based on the data that we have and based on the statistical significance values that we consider, the p values that we consider. So the basic assumption here that we always consider is that if the p value is greater than significance value, then we fail to reject the null hypothesis, and if the p value is less than significance value, we reject the null hypothesis. So what I have done is for every input feature I have considered my output feature as fraudulent, and I have checked whether my every input feature is independent or it is dependent towards the output feature. So similarly for every other column based on their data type, we need to consider different types of tests. Like we can consider z test, we can consider t test, we can consider chi-square test. Alright, so in this case, since majority of the columns that we have are of type object, so in this case we need to consider the chi-square testing. So these are the libraries that we have uh, imported, and these are just some basic pre-processing, and accordingly for every other column we are applying over here chi-square testing. Once we apply the chi-square testing for every column, there is one common observation that we can see, that every input column that is that every output column that we have is dependent towards the input every other input column. If I see over here that fraudulent column is dependent on education column. Similarly, if I go towards industry, same thing I can observe over here as well. Fraudulent column is dependent on the industry column. So the code is simple, it's just basic some libraries that we need to import over here, and accordingly we need to import the sts.chi-square contingency to get my statistical test statistics p-value, degree of freedom, and expected values. So accordingly we can do this for all of my columns, and I have mentioned over here for all my columns. And then accordingly after this, at the end, what I have done is I have done my machine learning modeling. So for this, obviously we don't need to consider all my columns, we only need to consider the columns that we need. So I have considered the columns that we need in the end, and then just for my machine learning model to be better, converted all my numeric columns into numerical integers. Now it's just some simple functions where I just split my input and output columns, and then I did the train test split based on 70-30 ratio, but obviously it's just hyperparameter. We can consider different train set size, train test sizes as well. And then accordingly we have several parameters that we can consider. We can consider accuracy, precision, recall, f1, confusion matrix, and AOC. But now here's one thing that I also made some analysis towards which metric is most important over here. So see, since our objective is to understand whether our data is real or job posting or not, right? So obviously we don't want to predict any real-time job as fake job, and we also don't want that a fake job be predicted as a real job, right? So either of these things are critically important, which means that in this case both my precision as well as recall is very important. And to balance the effect of both of these precision and recall metrics, the only best metric that we can consider here is f1 score, that we should consider in this case, business case. So accordingly, I just made a defined evaluation function over here, which prints out different metrics over here. And then accordingly, I consider different machine learning algorithms. Here I consider logistic regression. If I go below, I considered SVC algorithm. Below, I considered the random forest. So I can see that neither of these three columns, machine learning algorithms, gave me a very good F1 score, which means that I need to think of something more than this. Now, obviously, the fact that there are also text columns as well, I need to consider my NLP techniques as well. So one NLP technique that I have considered over here is a pipeline of basically count vectorizer and TF-IDF transformer along with SGD classifier. And when I consider this and my considering my class weights, I get a very good F1 score of 0.82, which is very good in comparison to other previous models. And if I just consider it for my test data, then also I get an F1 score of 0.67, which is fairly good. It's not very good, but compared to other previous models, it's good. So I can see that this model has performed better than the models which considered only the numerical columns. Accordingly, as for my entire analysis, statistical and ED analysis that I've done for all my columns, I have mentioned my observations and insights, and I have mentioned accordingly analysis on test data, statistical analysis, and this is my for numerical categorical data. Also, if I tell you about the plotly plots, interactive plots, which we weren't able to see them, so you can see it in my Kaggle blog over here, which I have mentioned over here. It's just a medium blog I have posted over here in this link. If I just go into this link, this is my blog. So this is my blog which I wrote about my problem statement which I worked on. So initial part of this is the same which I've done over here. So these are some of the interactive plots which we weren't able to see over here, but here we can see them because I've already combined over here with my blog. So all, not all, but the ones where I have imported the plotly library, you can see these are interactive ones. So this is just a plot of minimum maximum salary and has company logo. So this is just one of the plots. Similarly, if I just go below, this is for fraudulent, employment type and salary range. I can easily interact with it. Similarly, if I go down below, there are several other plots which I can see over here. So all the analysis that I could have done out of these plots, I have mentioned them as well in this blog of mine. Please feel free to go through this blog, and if you have any feedback that you may or may not want to give, you can anytime you can give it over here in my Kaggle blog. And similarly, there are just some more plotly plots that I have here, and accordingly, like I've mentioned all the text analysis, ED analysis, statistical analysis that I've done over here, all the key points I've done. And this is just another variation of URLs, phones, emails with fraudulent data. Accordingly, some other more plots as well I've considered. This is also another plotly plot for categorical data. So similarly, now if I go towards the EDF for text columns, these are all the plots which I've already shown you. And if I just scroll down a bit here, so these are all the machine learning algorithms which we considered initially, and then I've made my analysis over here that the best metric we need to consider is the F1 score. I've given my reasoning over here as well, and then we considered the TF-IDF count vectorizer in this one, and we got the best accuracy over here, F1 score over here. So this is my entire journey of this project, real fake job posting prediction, which I have worked on. There can be still more future works which can be very well performed over here. I have mentioned them, and these are just some of the references which I considered for my blog. So this is my blog, and this is the this is my uh, code which I've worked upon. So thank you.